Hello! This video will prepare you for your Unit 7 Formative 1, and it will also be a great reminder to look through later when we take the Unit 7 summative. So make sure you come back and re-look through this at the end of the unit. This video will cover three main topics: how to identify lines, rays, and line segments, also how to label them properly, drawing and measuring angles using a protractor, and similar figures. Identifying lines, rays, and line segments. First, you need to identify a line in this picture. Remember that lines extend forever in both directions. If you look at this figure, there is only one part of this that goes on forever in both directions. You can see that by the arrows on both ends. So to identify my line, I need to label it with 2 points on the line. Points C and D lie on that line. And of course, to label it a line, I need to put the line symbol above it, which has 2 arrows on the end. And that indicates line CD. Next, I need to identify a ray. A ray has one starting point, or one end point, and then it goes on forever in one direction. That is this one right here. It has a starting point, and then it goes forever in that direction. Again, that ray needs to be labeled or identified using 2 points on that, and the 2 points on that would be AC, and you always want the arrow to be above the point where the line continues forever in one direction, so that arrow would have to go above the C. A line segment has to have 2 endpoints, and if you look at this figure, this is the only part that has 2 endpoints. So that is identified by point A, B, or if you also look at that, you could consider part AD as a line segment, or you could even look over here at line segment AC. Both of them have a beginning and an end. And then also you could do DB down there. So there are lots of different line segments. Whichever line segment you choose, make sure that you label it correctly with no arrows on the line above. So you could do AB, you could do DB, we mentioned. You could also do line segment AD, which is part of a line. And then we also talked about AC. Make sure that those lines, again, don't have arrows above. And then we want to identify angles with vertex C. Angles with vertex C mean that C is in the middle. I'm going to grab a different color so you can see what I'm working with here. So I want point C to be my vertex. Now I can see 4 different angles here. I can see angle 1. And I can see this angle here, and I could find this angle here and this angle here. For the purpose of naming these, I'm going to add in 2 more points called E and F, and now I can label all 4 angles with vertex C. My first angle with vertex C, make sure that you put that angle sign in front, and you would start with A, C, E. And again, that is that first angle that I had highlighted. Another angle would be E, C, F. Another angle would be F, C, B. Nope, sorry, F, C, D. My apologies. And then my final angle would be angle ACD. All of those are highlighted in yellow. Remember that your vertex should always be in the middle. Notice how C is always in the middle. The next skill would be drawing and measuring angles. And to do both, we use this tool over here called a protractor. And the first one is to measure angle ISC. So you want to make sure that this is lined up perfectly along the bottom. You don't want it too far up, and you don't want this off to the side. You want it perpendicular to your vertex, And then I check to see how big this angle opens up. If you notice, this angle opens up this way. And so it would start as the small numbers. It wouldn't start as a 180-degree angle. So I'm looking at the numbers on the bottom, because as it opens up, my angle gets bigger, not smaller. So the number on the bottom, I can see it sits between 110 and 120. And it's a lot closer to 110 than it is to 120. So my best estimate for this degree measure is 112 degrees. And you can be off about a degree or two. Now the other part of this is to draw a 64-degree angle. In order to draw a 64-degree angle, I have to start with a ray, because all angles start with a ray. So I start with a line on the bottom, and then I take my protractor and I line that up as straight and as flat as I can, and sometimes I have to rotate it, and I want that lined up perpendicular. And then I want to come up on my protractor and see where this would open to be a 64-degree angle. Again, I don't start with a 180-degree angle. I start with a 0 degree. So I'm not using the numbers on the top. I'm using the numbers on the bottom. And so I'm going to open this up so that it comes a little bit past 60. Not quite to 70, so a little bit past halfway, and I make a little line where that should be. And then I just take my protractor and I rotate that. That moved my mark. I'm sorry. Let's try that again. All right, so if I want to make, I'm going to make a mark way up here. So if this is 64 degrees, it is up here. This should still work. I can still connect it to my vertex. Then I am going to take my protractor and rotate this and use my straight edge. Obviously, I don't have a real straight edge on my iPad, so bear with me with this line. That is not going to be perfect. And then I can move my protractor away. And then I add an arrow on the top, and there is my 64-degree angle, which is less than 90. I can tell that that one is smaller. It is acute. And my first angle was bigger than 90, so it makes sense that that is 112. The next topic is similar figures. Similar figures are two figures that have the same shape but different size, so one is usually larger or smaller than the other. And to see this, or to prove it, your corresponding angles, or your matching angles, are congruent. They are exactly the same. And your corresponding sides, your matching sides, are proportional. So let's take a look at these angles. This angle sits in the same spot as this one, or it's matching, and they are both 75 degrees. 65 degrees, 65 degrees, 40 degrees, and 40 degrees. So all of my corresponding angles are congruent. They are the same. Then I check the sides to see if they make a proportion. If you look from the red triangle to the green triangle, to go from 10 to 5, you divide by 2. And you could check to see that that's true all the way around. So from 12 to 6, you divide by 2. And then from 16 to 8, you divide by 2. Now sometimes you don't always get numbers that are that easy. So you want to be sure that you remember how to set up proportions, because you can check for two sides being in proportion by solving a proportion. So if I set up a proportion, I could say that 10 on the left triangle, so this side matches this one, and this one matches this one. So you could say that 10 is to 12 as 5 is to 6. And if those are truly equivalent, or if their cross products are equivalent, you know that they are in proportion. So if you check cross products, 10 times 6 is 60, and if you check 12 times 5, that is also 60. It means that those two figures are similar. Also remember that those are just two equivalent fractions, so if they simplify to be the same thing, then you know that they are also in proportion. And last but not least, you need to check for similarity. There are two things that you can look for similarity. One is that the corresponding angles are congruent. And if you look at this image on the left of the angles, you can see that they show this by these angle markings. So this shows you that this matches with this triangle down here because it has one little mark. This part right here matches that part right there because it has two of the little marks. I'm going to grab a different color. You can check this one and you see that it has 3 marks, so it shows that those 2 angles are in fact congruent. And then you can look at any of those other triangles and see that all of those angles match up. For example, this angle matches with that angle, matches with that angle, and it's shown by the 1 corner marking. Or you could check out the other one. For example, this angle is congruent to this angle because it has the same number of marks, and it's congruent to that one. So that's how you show that angles are congruent in figures. Now again, the other way to check for similarity is that the sides are in proportion. So you just need to make sure and set up proportions. So if I perhaps want to check for these 2 trapezoids, all I have to do is set up a proportion with those corresponding sides. So for example, if I wanted to match up this side, it would be with that matching side over there. Or perhaps I want to do the bottom number, which is 9 and 6. And I could check those for proportionality by setting up a proportion. Maybe I'm going to do this one on top. I'm going to put this one on the bottom. So my first fraction in my proportion is going to be 6 over 9. Then on my other one, I just want to put the corresponding sides in the right spot. So over here I would put 4, and down here I would put 6. Now you can go through and do any of your proportion shortcuts. You can simplify fractions, you can use cross products. So if I did want to simplify fractions, I could divide both of these by 3, and I would get 2 over 3. And this one I could divide by 2, and I would get 2 over 3, and 2/3 is in fact equal to 2/3, so I would know that these sides are proportional. Or you could go back and do cross products. 6 times 6 is 36, and 9 times 4 is 36, and those are also equivalent. So I know that these 2 trapezoids are similar because their sides are in proportion.